Design engineers increasingly want to rely on optimizations, and we want to bring these optimizations to machine design. By doing so, we can maximize the performance of machines. We can speed them up and make them more accurate. And at the same time, we can minimize the cost of the machine and the energy usage. By doing so on different cases, we obtained gains up to 50%. I'm Stijn Ramelaar. I'm professor in mechatronics at the University of Antwerp. And here at Cosys-Lab, we're at the forefront of co-design of cyber-physical systems. These include robotics, 3D sonars, and complex moving machines. Our niche is especially optimizing the movement of these complex mechanisms. Let's take a closer look at some exciting machines in our lab. The ball juggler here is a typical example of a repetitively moving mechanism. And as you can see, we can play with the motion profile of that movement. With altering the motion profile, we can have exactly the same result. And you see, the changes to the motion profile are quite small. But if we take a closer look, we see that by optimizing this motion profile, we could reduce the energy usage of the machine by 38%. This makes it possible to select a smaller and cheaper motor and at the same time spare energy when the machine is in use. To do so, we use an optimization algorithm. As you can see here, an optimization algorithm plays with the design parameters to find a certain better objective value. However, different runs of the optimization algorithm can give you different results. Of course, this is quite confusing and cumbersome for machine builders, as they're never sure that they find the really best solution for their problem. They don't know, should they run the optimization algorithm another time, and might there be a better design? Therefore, we want to make sure that we find the really best value, that we find the design that cannot be beaten by any other design or by any other machine builder, by playing with the design parameters. In scientific terms, this is called the global optimum. And we distinct ourselves from other groups doing optimizations by ensuring that we will find the one true global optimum and that you will never be able to find a better design. Our optimizations are by no means limited to motion profile optimizations. We could consider the complete drivetrain of a machine. We have different components, possible different geometries, etc. Here in this case of the ventilator, which is used to help patients breathing in emergency situations, we optimized the design of this machine by playing with the lengths of different components and also by playing with the mounting positions of different components. By doing so, these simulations helped us to define the most energy efficient variants of this machine. With our algorithms, it became possible to design a ventilator machine which is 43% more energy efficient, and we can use a 47% cheaper or smaller motor to do exactly the same task. Being more energy efficient is very valuable if you want to use this ventilator in places where there is no guaranteed electricity for 24 hours a day. We want to find the one true global optimum with lots of design parameters ranging from the motor, different components, the controller, the motion profile, the geometry. We can go up to 25 design parameters. And at the same time, we need a complete view of the response surface here. And to do so, we perform simulations. Of course, if the number of design parameters increases, the number of simulations would explode if we want to have this complete overview. Therefore, we heavily rely on novel and innovative techniques in sparse interpolation to use a minimum of simulations to have a complete overview of the response surface. In conclusion, we support machine constructors in their design. We let them optimize their design with lots of design parameters, and we guarantee that our algorithms will reveal the best possible design. This helps these enterprises to increase their market share in a competitive European and worldwide market. By doing so, we built up a network of around 15 small and medium enterprises, but also 5 international players active in Flanders. For that, we collaborate with the University of Ghent. They have a special expertise in CAD software, and we build optimization algorithms on top of that. Moreover, we are part of Flanders Make, the strategic basic research center for the manufacturing industry in Flanders. All this helps us to incorporate Industry 4.0 design techniques in the methodology manufacturers use.